Hello everyone. On behalf of Pembina Institute, I'd like to welcome you to the latest installment of our webinar series, The Future of Hydrogen and RNG in Canada, Decarbonisation Challenges and Prospects for Heavy-Duty Transport in British Columbia. I'm Simon Dyer, Deputy Executive Director of Pembina Institute, based here in a very hot Edmonton, Amiskwa, Waskahagan. I hope everyone's staying safe and keeping cool. To start, I'd like to acknowledge we're joining you here on Indigenous land in Treaty 6 territory. Here on the banks of the North Saskatchewan River in Edmonton, a traditional meeting ground and gathering place for the Cree, Saulteaux, Blackfoot, Dene, Nakota Sioux, and Métis people. And my colleagues in Vancouver are hosting today's event from the territories of the Musqueam, Squamish, and Tsleil-Waututh First Nations. We're grateful for the stewardship of these lands and waters since time immemorial. If this is your first interaction with Pembina Institute, we're Canada's leading independent clean energy and climate think tank, known for our work with government, industry, and communities in advancing clean energy solutions across Canada. So what are we talking about today? As we look to meeting our near and long-term climate targets on the pathway to net zero, transportation emissions continue to represent a large share of these emissions, and particularly emissions from heavy-duty vehicles, which are a growing segment of these transportation emissions in Canada. In fact, the Government of Canada predicts that emissions from freight transportation will surpass those of passenger vehicles by 2030. Heavy-duty vehicles are the highest fuel users. They travel the longest distances and carry the heaviest loads. In British Columbia, they represent 40% of on-road transportation emissions. Unlike passenger vehicles, where a combination of battery electric and hydrogen fuel cell electric vehicles are expected to fulfill demand, a wide range of fuel and technology options are likely to be required to meet the decarbonisation needs for heavy-duty vehicles. With this range of options come a number of challenges and opportunities, which our expert panel, who you'll meet shortly, will address today. Before we really get into things, I want to thank our partner, Fortis BC, for supporting this webinar series through their Climate Action Partners program. We're also grateful to the Real Estate Foundation of BC, the Sitka Foundation, and the North Family Foundation for their generous support of our work. If you'd like to support our work, or if you see anything you like the sound of today and want to get in touch, please contact us at pembina.org. And now I'd like to introduce my colleague Tara Jutt, who's the Director of our Clean Economy Program in BC, who's going to be today's moderator and will introduce our panel. Over to you, Tara.
Thank you, Simon. Hello, everyone, and welcome to Pembina's webinar on decarbonizing heavy-duty trucking. I'm Tara, your moderator for today. Just a few notes before we get started. This webinar is being recorded and will be available on the Pembina Institute website at pembina.org in the coming days. All participants will be muted during the webinar. We have allotted time for questions after the presentations. Please use the question box to type in your questions, and we will respond to as many as possible during the hour. So with that out of the way, let's get started. Almost everything we use in our daily lives is transported at some time by trucks. It's a critical and necessary mode of transportation that must decarbonize along with other sectors. However, for the heaviest trucks, options have been limited, but this is changing. Today, we're pleased to have an expert panel to help provide insights on some of the challenges and opportunities to decarbonize heavy-duty vehicles in BC and more broadly in Canada. Our speakers will help unpack some of the complexities of the industry, provide fleet perspectives, address technology readiness, and what policies can be implemented to help accelerate the transition. So without further delay, I'm pleased to introduce our panel. Today we have Dave Earle, President and CEO of the British Columbia Trucking Association, Karen Hamberg, Chair, Clean Technology Economic Strategy Table, and Chair Emeritus at CALSTART, Nicolas Pocard, Vice President, Marketing and Strategic Partnerships at Ballard Power Systems, and Traci Kraus, Director of Government Relations at Cummins. Cummins Inc. Our first speaker is Dave Earle. Dave Earle is the President and CEO of the BC Trucking Association, which is a member-based, province-wide, nonpartisan, nonprofit motor carrier association created to ensure a safe, efficient, and responsible commercial road transportation industry. His national board appointments include the Executive Board of the Canadian Trucking Alliance and Policy Development Committee, roles where he works to advance safety standards in the commercial transportation industry at the federal level. He's also Secretary-Treasurer of the Canadian Hoisting and Rigging Safety Council formed to create dialogue on harmonization to improve hoisting and rigging safety standards across Canada. Dave's provincial roles include past president of the Employers Forum and chair of the policy committee, representing the business community's interest to advance occupational health and safety standards. He's also a vice chair of Skill Plan, a nationally recognized leader in workforce development, which is governed jointly by building trade unions and business. Dave, over to you when you're ready.
Thanks for having me, and thank you everybody this morning. I have a short presentation I'm going to go through very, very quickly. Really want to open the space for some dialogue. When you heard our opening remarks in terms of British Columbia, where the GHG footprint really starts to bite in British Columbia, commercial transport is a very, very large portion of that emission profile for a variety of reasons, but certainly it's something that's top of mind for our members as we go forward. It's a key strategic imperative for our association to assist our members in working with government to say, what can we do? What is the art of the possible? We did a lot of analytical work during the COVID times, going through and looking at data. That's what I want to share with you today and provide a bit of context and background as to what our members face on a daily basis. More than anything, I really invite everybody to take a look at the data. Any questions you have, by all means, reach out to me. Be more than happy to share the source data and analysis with you. Love for somebody to tell me that that we're wrong, frankly. So next slide, if you could, please. So what are we talking about? Very quickly, we've got about 60,000 heavy, these are over 11,794 kilogram vehicles registered in BC, and about 160,000 medium vehicles registered in BC. We have no method to know how many extra provincial vehicles transit BC, but based on IFTA data, the International Fuel Tax Agreement data, best estimate is a like number. So about half the vehicles that are operating in BC are actually registered here. With our membership, the vast majority of our membership is almost strictly heavy duty. About half of our members operate interprovincially. There are 16,000 trucking companies registered in British Columbia. Of those 16,000, 22 have 100 or more employees. That tells you how fractured the industry is. It is comprised mostly of extremely small fleets and or independent owner operators. The most visible sector that the public sees, particularly Metro Vancouver, is the drayage sector. This is the containers that are moving in and out of Vancouver's ports. As of December 7th, we had 1,661 trucks in the drayage fleet. It's about 1% of the industry. So while it's very, very visible, it's a very, very small part of the industry as a whole. Kind of gives you context of the size of the industry. Next slide. Emissions. Historically, the number one cost for carriers is diesel. This is the number one consumable cost. There is real motivation to reduce consumption. BC-based carriers, about 29% of our members tell us on average that's their operating costs are related to diesel. It can be up to 51%, depends on the route. Our topography works against us. When you're hauling freight up and down through mountain passes, you burn an awful lot of fuel. The emissions that we talk about are nitrogen oxides, oxides of nitrogen, sulfur, particulate, and GHG emissions. NOx, SOx, and particulate were addressed in legislation in both the US and Canada, model year trucks 04, 7, and 10. The problem was the technology was not developed. Industry said clearly to the EPA in the United States that the technology is not here. We don't know how to do it. We're going to have to come up with something that's not going to work very well. And they did, and it didn't. While by 2010, in the main, NOx, SOx, and particulate were eliminated. It's a significant capital cost. Reliability was a real problem. These vehicles were down for maintenance because of the emission control systems anywhere from 10 to 15 days a year, and your fuel consumption actually went up. So while we eliminated NOx, SOx, and particulate, we saw GHG emissions increase between 5 and 10%. This is a similar situation if you're familiar with the Volkswagen Group scandal in the light vehicle world, where the manufacturer said, we don't know how. Volkswagen cheated. This is very similar in the heavy world where the technology wasn't there, it doesn't work. So what we have is this proliferation of delete kits where trucks are programmed or equipment is removed so the emission controls don't work. Glider kits where new chassis are manufactured and an old engine is put in. When I say an old engine, an old design, the number one type of engine that's put in is a 1999 Detroit diesel. extremely fuel efficient, and bulletproof. You know, all of this is to try and get to a point where they're reducing their diesel burn. To fix these delete kits, refitting if possible, because some of these parts don't even exist anymore. Even if we were to go back and fix this issue, it's going to relate to a 5 to 10% increase in GHG emissions. So next slide. So let's talk about zero emission vehicles. Where are the unicorns? You've all heard about them. Where are they? So by a thumbnail sketch, Nicolas, they're out. They're only doing class 6s and 7. There was a partnership with GM, then there wasn't a partnership with GM, then there's kind of a partnership with GM. Their factory is under construction in Arizona. We'll have to wait and see what comes. Tesla, they're going to have their semi on the road in 2019 or 2021 or something. They are running. The Tesla semis are running, particularly moving their product and their cars from the manufacturing factories to their stores. They're coming. There are some challenges there, but they're coming. All of the major equipment manufacturers have projects. Lots of pilot projects going on, lots of really interesting learnings. Terminal to terminal operations, primarily in the Southwest and Southeast United States. Port of Los Angeles, Long Beach has had a pilot project in place for a couple of years with electric zero emission vehicles, hydrogen fuel cell vehicles. In Canada and BC in particular, we have 2 vehicles that are available for purchase. Today, one of them is an electric BYD. It has about 120 kilometer range, which is not good for anything other than really running as a shunt truck in a yard, and Lion Electric with an up to 400 kilometer range. The Lion Electric trucks, you can order them, you can't get them yet. The semiconductor supply chain problems and the other supply chain constraints are really hampering production. We have no fuel cell vehicles on the market for purchase, but we do have hydrogen co-burn systems on the road now. A couple of our members have been working in partnership with the hydrogen co-burn proponent in, of all places, Prince George, and our government just committed to supply $1.9 million in funding this week to further that study. Hydrogen co-burn is exactly what it sounds like. Hydrogen is intermixed with diesel to reduce emissions. Next slide. So what are we talking about? And today we're going to talk about, and I'm really looking forward to hear, what are we looking at for solutions? And the opening remarks, I think, are important. In our view, we're into the VHS versus beta. What are we talking about? Do we look at electrification? Do we look at hydrogen? And the answer is, yeah, we do. We look everywhere. What we know about electrification is it's unproven, but there's a big potential here for return to base operations. That's why the projects that are going on around North America are so important to study and learn from. Infrastructure is expensive and not always possible because of surrounding grid requirements. There's no quick emergency recovery, and there's long charging time. Even the Tesla vehicle, and they're talking about 90-minute recharging time, that's with not 1, not 2, but count them, 4 superchargers running for 90 minutes. A vehicle that's going to have to recharge for 90 minutes every 400 kilometers is going to have real impact on the supply chain. There's also a TARE, empty weight penalty, about a 10% reduction in efficiency with electrification versus standard diesel vehicles. And there's a pretty scary capital cost associated with these vehicles. That will come down over time, but right now it's pretty scary. Hydrogen, the infrastructure is rare and expensive. Gray, blue, and green hydrogen, you all know color matters. And we have terrifying capital costs at this point because, again, it's new technology. So next slide. And so what are we talking about? Why do we care about this? So we took a look and said, what can we do? How can we get to our goal of reducing emissions for 40% by 2030? So remember, we got about 60,000 vehicles in BC. We know BC's fleet grows by about 600 vehicles a year. We know the average model year in the fleet is 2008. We know the average fleet turnover is about 2.9% a year. So, roughly 3% a year gets us 1,800 fleet sales per year, about 600 for new growth, and that aligns with the 2,400 new units we hear from our OEMs in the province. So we said, great, that's our bucket that we have to work with. So then we looked at it, so what can we learn from? Well, 2008, we saw the first ZEV light vehicle sold in BC. As of 2020, we have 10% of all new car sales being ZEV vehicles. What that equates to is after 12 years, the market penetration for ZEVs in BC is about 2.4%. So where are we at? 2021 will, and I put maybe because now we're into maybe territory, see the first ZEV heavy-duty vehicle operating on highways in BC. We've got a couple now, but they're shunt trucks. There's nothing operating on the highways right now. What does this all translate to? Next slide, if you could. So what do we have? This is a road transportation GHG emission profile. The purple line is what we know. The other lines are projected based on our fleet growth, turnover rates, and all those good things in life. We've got three cases. We have pessimistic best case and aggressive case. When we talk about aggressive case, we're talking about seeing zero emission vehicles being available in 2021. It's not going to happen. They're just not available. Lots on, we shouldn't say lots. There's a handful on order. We're aware of a variety of projects. If all of them come to fruition and we can figure out our supply chain constraints, we might get some. We're hoping to have, well, we better have a few on the road by the end of the year, but we're working on that. The realistic case, the base case, is looking at saying these vehicles will be available in numbers by 2023, and that's that blue line. The pessimistic case is that ZEV vehicles won't be available in numbers until 2027. That's, I don't think, going to happen. But our base case is that blue line, and you'll note it's pretty depressing. When we look at fleet turnover, we look at the growth in the fleet, we look at where we're at, and we look at the ZEV market, we say, you know what? If we rely on ZEVs, this is what we're looking at. It's going to continue to grow. Our GHG profile is going to continue to grow, and we're not going to see significant reduction until we're well into the next decade. That blue line across the bottom is where we want to get to. Like, we're not even close on this. So we said, well, what would it take? So next slide, if you could. So we looked at it and said, okay, so what can we do? So if we double our fleet turnover rate immediately, so double it, we go from 2.9 to 6%, and we get ZEV adoption at 750% of light vehicle rate immediately, doesn't work. So to get to 2040 reductions of our, 40% of 2007 reductions by 2035 requires 1,000% acceleration of zero emission vehicle adoption compared to the light vehicle fleet, and a more than tripling of fleet turnover by 10%. We can't, like, it's literally not mathematically possible. There's a whole bunch of reasons behind it, but this is cold hard math. To get to a 40% reduction by 2030 would require that every heavy and medium vehicle sale in British Columbia, all of them 100%, would need to be zero emission beginning this year. And it didn't happen. We can't rely on ZEV technology to get us to where we need to be. We're going to have to do other things. We're going to have to find other ways. The ZEV world's not going to get us to where we need to be. Yeah, it's going to change. Yes, it's coming. Yes, we're going to see those curves. They're not going to plummet like that. They will peter out as we go to the bottom of them, but we are going to see a turn, but it's going to take time. Last slide, if you could. So what do? Do more with what we have. We talk about right sizing. Well, with big fleets, that's possible, but not really with small fleets. This is simply not using big stuff when you can use small stuff. 94% of trucking companies are under 10 trucks. More than that, the principle of freight movement is aggregation. The bigger the stuff is that's moving around, the more efficient it is for a given set of goods. So we don't want to start fracturing the fleet for other reasons. You're chasing your own tail. We do have a heavy-duty vehicle efficiency program, which is encouraging and incenting carriers to adopt new technologies, trying different things, such as supporting the hydrogen co-burn project that we're doing alongside with government for members in the interior, all the way down as things as boring as aerodynamic mud flaps. Not kidding, aerodynamic mud flaps are a thing. We need to improve infrastructure, long combination vehicle routes. British Columbia right now can't use LCVs on anything other than our Coquihalla network. These are the vehicles, they're moving 2 full-size trailers behind them. From a GHG perspective, they're about 40% more efficient because they're moving twice as much freight with the same unit. We need to accelerate fleet turnover. We need to pilot, test, and build ZEV infrastructure. We need to celebrate the pilots, really find the champions and successes, and we need to remove red tape. Hybrid drive axles are available, but this is a red tape barrier that we're working with government to be able to adopt and be nimble and adopt new technology. In our view, we have to do a hell of a lot more with what we have. Yes, ZEV is coming. Yes, it's going to happen. Yes, it's going to get cheaper. Yes, in years to come, you're not going to recognize the commercial fleet, but it's not going to get us there quickly enough. We're going to have to do a lot more with what we have. And I think that's it. So thank you.
Thank you, Dave. That was really great presentation. It gives us a lot to think about, and it was a really great perspective. Our next speaker is Karen Hamberg. Karen is a clean technology executive with more than 20 years of global experience in the deployment of clean transportation technologies and the policy and regulatory frameworks required to scale companies and advance market share. She has expertise in corporate strategy, policy and regulatory affairs, market intelligence, ESG, sustainability, and external communications. Karen was previously Vice President, Sustainability and External Affairs at Westport Fuel Systems in Vancouver until December of 2020, an organization where she was with since 2001. In June 2020, the Honourable Navdeep Bains appointed her to the Government of Canada's Industry Strategy Council representing the clean technology sector and named her chair of the Clean Technology Economic Strategy Table. Karen is currently Chair Emeritus of the Board of Directors of CALSTART in California. CALSTART is the nation's largest nonprofit, member-driven coalition accelerating the growth of the clean transportation industry. Karen served as chair for 4 years. Karen is also an active volunteer, serving as the chair of the 2019 United Way of the Lower Mainland Cabinet, and she was also appointed to the British Columbia Regional Advisory Board of the Nature Conservancy of Canada in 2019. She holds a Master of Arts degree from Queen's University in Kingston and a Bachelor of Arts degree from Brandon University in Manitoba. Karen, when you're ready, please go ahead.
Great. Thank you so much, Tara, and thank you again for the opportunity to join and to speak to you. So I'm sort of setting things up here between the great overview that Dave has done here on market and then the really deep technology discussion that Nicolas and Traci are going to get into on technology. So a few things about the heavy-duty trucking sector. Dave has set this conversation up really well, and we understand then that the technology solutions are incredibly application specific. This is a highly fragmented market based on locations, fleet type and size, engine size, haul length, annual mileage, vehicle configurations, duty cycle, all of these drivers. And unlike light duty, where hundreds of thousands of units in production is the norm, the scale of heavy duty production is relatively low. And this is a significant obstacle to tech deployment, as cost reductions through high volume production are more limited and will be on a longer lag time. So with regards to the market then, and I will speak, I'm certainly not speaking on behalf of Westport, but I can certainly speak to my experience over the 20 years there. And what we've learned then is that technologies don't replace other technologies, systems replace systems. And therefore there must be this commercially, economically competitive network that requires very coherent commercial systems to be able to scale in this market. And so then we need to understand what pieces of the deployment ecosystem are still missing. Dave mentioned this. The significant proportion of annual Class 8 sales are into small fleets who are less likely to adopt new technology. So while we celebrate, we recognize, we champion, UPS, PepsiCo, Walmart, Amazon, IKEA, et cetera, those are very different fleets who have made a very strategic decision to become a rolling laboratory for alternative fuel technology. And the learning that we're taking from those early adopters are really going to drive scale in smaller markets. So we're certainly very grateful to them. But those smaller fleets, then we're going to need some kind of innovative finance models for them, maybe around some first loss protection requirements. We're going to need some government incentives to get them to move as well, to be able to hit those turnover numbers and the scale numbers that Dave has referenced so well. And I think one other thing too that's important to mention in this sector is that there's incredible competition for the fuel feedstocks with other industrial sectors. And so this applies whether we're talking about liquid biofuels, renewable natural gas, or hydrogen. There's lots of other industrial sectors that want to decarbonize, need to decarbonize, and they want to get their mitts on that fuel. So let me just talk quickly about Europe and the renewable natural gas experience. As you know, in Europe, April 2019, the EU passed the most stringent heavy-duty CO2 regulations, requiring a 15% emission reduction at 2025 and 30% at 2030. All the signals indicate that that target's going to be assessed in 2022, and we're probably expecting some more stringency on that. So the state of natural gas engines in Europe is really a story about some scaling here right now. We have 4 LNG engines above 400 horsepower that can deliver in a 1,000 plus kilometer range, commercially available from 3 different OEMs. One thing that was interesting here, I think it was announced in January, the Iveco Stralis, a dual tank 460 horsepower engine achieved the record of 1,700 kilometers on their dual tank system. So that is significant when we're talking about 200 kilometers range, 400 kilometers range. They are achieving 1,000+ kilometers on some of these engines in Europe in these different applications. I looked at the ASEA data set before this webinar. LNG is right now about 3% market share of new sales in 2020 in Europe. That works out to about 7,000 units. The demand is up 5.5% from 2019. There's 420 LNG stations across Europe in 20 different countries, of course, primarily Germany, Italy, France, UK, Sweden, the countries that we would expect. It's also interesting to talk about how the technology scales in this market, because we will see, evidence of successful pilots and demonstrations that then result into a commercial launch. Fleets will take 1 or 2 or 5 or 10 trucks, try them out, maybe dozens in their next order. We're starting to see orders now in the natural gas space of 202 in Europe. That's the largest order so far for LNG. UPS has announced 6,000 more of the Cummins Westport engine. Amazon earlier in the year announced 600 running on renewable gas. So we're seeing incredible attention on renewable natural gas. We are seeing numbers in Europe and US because of the commitment to decarbonization and the carbon intensity scores that RNG can obtain, is that fleets are moving first to renewable gas with a longer vision to true zero emission vehicle solutions. So that is certainly exciting. So I'm going to switch here into my work with CALSTART. And so for years we've been saying, the next 3 to 5 years are critical. Perhaps this has never been more true than right now. And Dave has shown how we're going to require some strong growth early to be able to transition our fleet to achieve the needed stock shares by 2040 and 2050. And what we know, market forces are not going to be enough to decarbonize this sector. We need some strong, some sustained, some adaptive policies that will reduce emissions for any of these transition scenarios that we're looking at. So CALSTART, as you may be aware, because they do work closely with Clean Energy Canada and with Pembina and others, even others within the Government of Canada, and Canada endorsed this strategy in 2018 at the Clean Energy Ministerial. This was a strategy that they built through years of work and investment with the California Air Resources Board and other OEMs, is that there are near and zero emission commercial vehicle beachhead applications. You can see them there in transit and delivery that are commercially viable, cost competitive in markets now and to 2025. And that if we continue to focus on collaboration, on supply chain scale up, on the volumes, the componentry, the systems, everything that's going to be needed to drive costs down, we should be able to see over time finally achieving true zero emission technology in wave 5, this point-to-point corridor, long haul, and certainly hydrogen fuel cells and battery electric are not the unicorn so much, because they are in different states of technology development and success commercially right now. So that's sort of how the market is transitioning then. So this beachhead strategy says certain segments were first movers. Transit was that, refuse was that. Because of their duty cycle criteria, they're more easily transitioned to zero emission alternatives. So let's take what we've learned then from those sectors, and is there an opportunity then, and how do we collaborate, work together across fleets, manufacturers, OEMs, government, and others to scale into these more challenging sectors where it's just going to be more difficult to decarbonize. So next slide, please. So this slide is also modified after work that we did with CALSTART and with CARB. And so because the success that they've had in California can really be tied to enabling conditions and enabling policies. I spoke again about how this is an ecosystem. So let's talk about this in sort of the context of Canada. So in Canada, in this sector, we have had significant R&D investment. We have had, incredible funding support for innovators. Even think of someone like Westport for the years that they had been, able to work with government on different programs, get investment for technology development. We have been, supported, and Government of Canada continues to put significant investment in technology solution providers. On the other end of the bookend, though, we also have carbon pricing, a clean fuel standard, and net zero legislation. But in the middle of all of that is what we call these enabling policies, these demand pull innovation policies, and concurrently the market enabling conditions that are going to enable this, these technologies to scale. So they fill this niche between, R&D investments for new scale technology, and then policies like carbon pricing that, support a large scale deployment. These policies really focused on creating these early markets for emerging technologies. They tend to be technology specific. They aim to lower barriers of market adoption, and they will create these initial market niches. Just think of what's happened in transit and refuse, and you can see that. So as I was preparing for this webinar then, I reviewed Pembina reports, Clean Energy Canada reports, ICCT, MIT reports on sustainable mobility. We know the recommendations, the policy type recommendations that have been advanced. So efficiency standards, renewable fuel standards, ZEV mandates, etc. But I just want to talk quickly about one of the challenges that I see as part of my role on the Industry Strategy Council that I've been working on for the last year. And so Canada needs an industrial strategy to build an economy that reduces emissions. And this is something that Minister Wilkinson, Minister Champagne, and others have been speaking about. And we need innovation policy that focuses as much on tech adoption as it does on technology development. So what does that mean in the context of Canada? California and Europe had a focused, targeted, intentional industrial strategy to scale heavy-duty transportation solutions. As we talked about this at the council, and you're seeing more policy wonks talking about this right now, the immediate criticism is government has no record of picking winners or losers, or government should not be in the business of picking winners and losers. And that's true, you shouldn't, government shouldn't, but government certainly can support leaders and can certainly make decisions on where Canada has comparative and strategic advantage in heavy duty transportation. So I could make a case, a very strong case, that Canada does have that leadership, whether it's through propulsion systems, Westport, Ballard, Efenco, Loop, Lion, others, technology solution providers like Freighterra, chassis manufacturing like New Flyer, a whole host, battery recyclers like Li-Cycle. There is this incredible expertise and depth in the heavy duty sector that is scaling and that is exporting to global markets as well. So we need some focus then on what supports do the companies in this sector need beyond sort of, capital or R&D investment decisions. This could be around regulations, it could be around talent, it could be around policy, access to markets, export supports, whatever that's going to be. Market forces aren't going to do it. We need to make some big bets here, and we've got countries around the world actively pursuing their industrial strategies to capture market share in advanced energy industries such as hydrogen, electric vehicles, and batteries, and we have this window of opportunity. So let's take it. Thank you.
Thank you, Karen. That was great. Really good to hear that international perspective on what's happening. Just a reminder before we go to our next speaker that if you have any questions, please feel free to type them into the question box and we'll get to them after our next speakers. I'd like to introduce to you next Nicolas Pocard. Nicolas brings more than 20 years of experience in business development and marketing at the international level to Ballard Power Systems. He joined the fuel cell industry in 2004 and Ballard Power Systems in 2012. Among his responsibility, Nicolas leads corporate marketing strategy, marketing activities, government relations, and strategic partnerships. In addition, Nicolas is the vice chair of the board of the Canadian Hydrogen and Fuel Cell Association and a board member of the California Hydrogen Business Council and of the Canadian Urban Transit Research and Innovation Consortium. He also represents Ballard with various industry associations and government forums. Nicolas holds a degree in chemical engineering from ESCOM in Paris and a Master's of Science from Ohio State University. Over to you, Nicolas.
Thank you very much, Tara. Very pleased to be here today with you and share a bit of the perspective from where are we on the hydrogen side and what is the role of hydrogen for the decarbonization of trucking. And as it was highlighted earlier, we are still at the beginning of that journey. Putting fuel cell in a truck is only starting and is not going to be widely available for the next few years. So to the point of made earlier, we need to work on how we're going to make it happen, and this is what Ballard is doing. Next slide. So we have started a journey at Ballard more than 40 years ago, and that's why we do a BC-based company here in Burnaby, and we are developing fuel cell technology mainly for heavy-duty mobility. We have, we have now over 85 million kilometers of bus and truck service on the road, mainly starting with bus and now moving to the truck market, and really showing that we have demonstrated that fuel cell works. Fuel cell can operate, fuel cell vehicle, bus and trucks can operate in different climates. So now the big challenge we have is how do we deploy them at scale and how do we reduce the cost? And that's very key. Next slide. So if you look at so why, at Ballard we are focusing mainly on heavy duty mobility. That's where we believe that hydrogen brings the best value proposition for application where you need a lot of energy because either of the the vehicle purpose in terms of weight and operation, long operating hours. So whenever you have a lot of energy needed in order to move a vehicle, so it can be a bus, coach, truck, train, or marine vessel, hydrogen we can play a critical role as one of the solutions to decarbonize this sector. Next slide. And the reason of why of that is really because of three key elements. There is hydrogen is light, much lighter at scale when you have a lot of when you want hundreds of kilowatt hour of energy or even thousands of kilowatt hour of energy needed compared to batteries. So there's no compromise on the payload, and that's very important. So hydrogen enables you to have a lot of energy packed on a vehicle without compromising your payload. Quick refilling of hydrogen, it takes 10 to 15 minutes to refuel a bus or truck, so you don't have immobilization of your assets. You can really optimize your truck, which zero emission truck are going to be for the foreseeing time more expensive than a diesel truck. So operators would like to use them as much as possible in a fleet base, maybe multiple shift operation to utilize the assets. So having a very quick refueling is very important. And because you have that more energy on board, you can also have a longer range. So the combination of the range, a quick refueling, and the no compromise on payload because of the lightweight of hydrogen really make them one of an attractive solution for those cycle of use case where you need to use a lot of energy, long routes, more difficult routes, and longer operating hours. Next slide. And I think the next slide does show, what was the impact on the weight and the compromise. And if you look between the battery electric vehicle and the fuel cell electric vehicle, and looking at the reduction of the cargo capacity compared to the range, and you can see the more range you have, the more battery you need, so the more compromise you have on the capacity. And this is really where hydrogen provide that, it's not, there's still a bit of degradation in today because of the weight compared to diesel, but it's minimum compared to what it would be in battery on a very long mileage. So we believe that fuel cell offers today on the hydrogen an interesting one as a solution to address the issue of medium mobility trucks without too much compromise on the range and also on the payload. Next slide. So where are we today? I think we, when you look at, here showing at, what does it make sense? Where we look at, if you have a short delivery, urban delivery, I think batteries does that very well. On the medium duty, and when you look at regional range, it's probably going to be a mix later on of really battery electric and fuel cell electric vehicle, depending on the use case and depending on the characteristic of the vehicle and how do you operate your trucks. But whenever you start to looking in longer distances or point to point or later, on long haul, hydrogen is probably going to be one of the best solutions for that. However, there's still some challenges. We're not there yet. We are still at probably at the first hour of the day, maybe not the first minute of the day. So we still have some work to do to be able to offer the truck drivers a solution which is also economically viable. Next step, sorry. And so initially what you want to do is to focus on application where you have either a fleet, so you are starting from the point and you come back to the point. So that's in order to address the infrastructure requirement. As it was noted before, hydrogen vehicle needs a dedicated hydrogen infrastructure to refuel the vehicle. The good thing is this infrastructure can be utilized by many vehicles. It's like a gas station with a dispenser where it takes 10 minutes per vehicle. Therefore, the investment you make in the heavy duty refueling infrastructure can be used by many vehicles. So starting maybe with a distribution fleet, having a fleet-based operation with a centralized depot refueling with the option like we're doing in transit world, and then looking at maybe point-to-point, like the projects we have in Alberta, where looking at putting fuel cell trucks in operation between Calgary and Edmonton, and having refueling at the end of the point-to-point line. Later on, whenever there's a network of stations, then you can look at on-demand long-haul distribution. But initially, really looking at application where you have depot bays, round trips where the fleet is back at night to a location, it can be refueled, and point-to-point where you can, or operating along the freight corridors where you have a number of stations to support the operation of the trucks. Next slide. So where are we today? I think today, there are probably around, I would say 5,000 fuel cell trucks in operation worldwide today. At Ballard, we have, around 2,300 trucks in operation today in cities in China. So looking at light to medium duty trucks, 3 to 9 ton trucks doing deliveries. Why not battery? Well, because those trucks operators want to operate those trucks 24 hours a day, multiple shifts to also use in the night when it's easier to deliver during the day as well. So fuel cell enables that multi-shift operation. Now there are numbers, as it was highlighted before. We are still at the demonstration stage of projects in California, in Europe, where we are, putting class 4, class 6, class 7, and class 8 trucks being tested and operated in small fleets. Today we have fleets of less than 10 vehicles at the moment. And it was mentioned, some of the pictures here of the class 8 truck at the port of Long Beach. And, projects we're doing now in Alberta, we're building 2 60-ton trucks, which would be an EZTEC project, which will be operating between Edmonton and Calgary. So early stage, trying in those bigger vehicle, and probably we'll see, probably the class 4 to class 6 vehicle moving a bit faster because it's less challenging in terms of hydrogen storage and fuel cell size, and also the cost reduction can go faster. And I think that's the next really key item. And next slide. So the cost. It was qualified earlier as a terrifying cost. Yes, today fuel cell or battery electric vehicle are much more expensive than a diesel vehicle, but we believe that within the next 10 years, by the end of the decade, a fuel cell truck can be the lowest, offer the lowest TCO for commercial application. So where are we and how are we going to get there? Next slide. So as you can see from that slide, today the cost of a fuel cell vehicle is higher than the cost of a battery vehicle, and but the cost reduction we are working on it. As a company at Ballard, that's what we do. We develop the fuel cell engine, so we are really working on the technology. So after proving that technology works and it lasts, and we have shown that the fuel cell can last for 30,000 hours, 35,000 hours of operation in a bus city. And now we need to succeed in a cost reduction. We have a very ambitious plan. We believe that we can, on the stack itself, which is the heart of the fuel cell, at Ballard, we have a plan to reduce the cost of the fuel cell stack by 70% by 2024. And then working with the supply chain, we believe that we can reduce the overall cost of the engine in order to meet actually the DOE target and be around $100, $120 per kilowatt whenever we start making tens of thousands of those engines. So a fuel cell is is like an engine made of aluminum piece and carbon and pipes and wires. So it's a manufactured product, and as we are scaling up now, going to industrialization of the technology, this is why we can really go to this steep cost reduction curve, because it's all about industrialization in order to meet the cost requirement. So we are confident as an industry that by the end of the decade, we can have a fuel cell engine at the equivalent cost of a diesel engine whenever we make them in volumes of tens of 50,000 per year. We need the volume to succeed in the cost reduction, but it's on the way. We've already drastically reduced from what it was 5 years ago, and we're continuing down that path. Next slide. And yes, so just want to finish that by saying fuel cell technology works. It has proven to be very well to last, to deliver the quality of service in terms of operation in the transit world, in the bus world. Now, as we are going into the truck world, the big challenge is really on the cost reduction, and this is what we are addressing as an industry on the technology itself, on the fuel cell powertrain, but also as well on the fuel cost by developing those hubs across Canada in order to develop affordable, low carbon hydrogen source for the truck driver. Thank you very much.
Thank you, Nicolas. That was really informative, and I think we're all looking forward to seeing a time when the costs come down and that we see more hydrogen trucks on the road. Our next speaker is Traci Kraus. Traci is the Director of Government Relations at Cummins, Inc. She represents Cummins as a co-founder of the Hydrogen Forward Coalition, co-chair of the Hydrogen Council Policy and Advocacy Project Team, and chair of the Truck and Engine Manufacturers Association Public Policy Committee. She leads advocacy for Cummins engine, new power systems and components business units, product compliance and regulatory affairs, and research and technology functions. She focuses on energy, climate, hydrogen, transportation, and budget and legislative and regulatory issues. Prior to joining Cummins, Traci worked for U.S. Senator Russ Feingold. She has a master's in public administration from George Washington University and BAs in government and politics and communications from the University of Maryland in College Park. She's originally from Chicago and now lives outside of Washington, D.C. with her husband and 2 children. Over to you, Traci.
Thank you so much, Tara. And I am trying to get my webcam up and running, so give me a moment to do that, but I will just tell you a little bit about Cummins while we get started. And I believe I'm not seeing my slides on my end, but I will just assume that you might be seeing them on your end. And I wanted to talk a little bit about Cummins and where we are right now. So we're a global technology leader with a broad portfolio of power solutions. And what I mean by that is right now we provide engines for about 40% of the trucks you see on the road, but components for about 90% of the trucks you see on the road. And those engines traditionally have been diesel, but along with Westport, we make the only natural gas engines available. We've also invested significantly in both battery and hydrogen technology. So we make hybrid and battery electric powertrains and fuel cell powertrains. And we even now have invested in electrolysis. So investing in the company Hydrogenics based in Canada, which has electrolyzer capabilities. So really operating throughout that value chain in heavy duty trucking. And I'm on my slide 3 now, Colton's, because I'm seeing them pop up now. But we also, you can see we serve many markets and applications. So, a lot of folks, when they are typically familiar with the passenger car segments where you're talking about a few different sizes. But in heavy duty trucking, as you heard the earlier panelists refer to, there really is great diversity from everything from, the long haul heavy duty trucks to transit buses, school buses, Cummins supplies engines for construction equipment, oil and gas equipment, agriculture, defense, mining, and even marine. So because of that diversity of applications, we really do see a need for a variety of technologies to decarbonize. Next slide. And because of that, we've set some really ambitious targets for us to have a goal. And those targets do align with the science of the Paris Climate Agreement. So Cummins has committed to reaching net zero carbon emissions in all of our products, facilities, and operations by 2050. We also have pretty aggressive targets on NOx emissions and also using our resources in the most sustainable way and waste and water. Next slide. And the reason I mentioned that we have such aggressive targets is because we do see the necessity of getting to zero emissions, as I said, in all of our products and operations. So that plan is really the fundamental, what are we going to do? And then we are working with regulators and policymakers on a bold technology and regulatory roadmap to achieve that goal. And we do think that our plan, using all of these different technologies, is the best way to reduce the most emissions in the least amount of time for the least cost for our customers and for society. Next slide. And so this plan, right, and I'm not going to go and give you every little detail and product plan today, but we do have significant engineering resources across our over 60,000 employees globally. We operate in over 190 countries. We have significant engineering resources. And we've also spent a significant part of our revenue on research and technology. So we do invest heavily into our products. And so I told you a little bit about what we're doing in the hydrogen space and the battery space, but we're continuing to invest in diesel technology to continue to reduce both carbon and NOx emissions. So we do not think that we're at the end of the road there. There is more to be done to make those engines both more efficient, but also less polluting. And we have 55 tech centers around the world committed to working not only with the local regulators, but also the local communities to ensure that we're developing the best products everywhere that we operate. Next slide. And so I wanted to dive a little bit more into some of those new technologies that we're working on. And certainly not new to Cummins, but new to some of our commercial availability. Part of that is electrified power. We do have battery capability. And right now there are Cummins battery powertrains on the road in transit bus, school bus, medium duty truck, and walk-in van. We've also deployed in construction equipment, terminal tractor operations, and material handling. For fuel cells, creating and integrating components for fuel cell electric vehicles and rail is critical. In fact, we are the leader of hydrogen fuel cells for rail right now, with passenger trains in operation in Germany and also deploying in Austria and France. We have urban transit fuel cell buses and commercial fleets looking at our fuel cell technology. And we also do significant work really throughout the value chain, but that includes investment in tank technology, but also hydrogen generation. So we have the largest electrolyzer producing hydrogen in North America in Bécancour, Canada. And we also have the largest in the US in Douglas County, Washington. And, we talk a lot about hydrogen and how really to achieve scale, it's not about the color. So I'm sure you've heard blue hydrogen, gray, green, and of course our electrolyzers using renewable energy can make, what's referred to as green hydrogen, but we really like to talk about the importance of decarbonized hydrogen. And I'm gonna just I know we're running a little low on time, but I wanted to briefly get into some of the things that I advocate for with policymakers. So next slide, and why that decarbonized hydrogen is important. But we really do think, right, of course, we are doing everything we can on our product side, but there is a lot that needs to be done by policymakers as well. Part of that is continued innovation and scaling for low carbon fuels. And I have two slides. I think, Colton, you're at complementary measures now. They really are quite similar, but so if you can go back one, so the importance of low carbon fuels, and then of course, decarbonizing and modernizing the grid. So not only does that include decarbonizing by adding more renewables, but also really making sure that the transmission and the infrastructure of the grid is capable to handle a significant additional load, developing the hydrogen economy from production and distribution, and then really improving the efficiency of converting energy to useful power. And then I'll just wrap up on the next one. On the complementary measures. And those are the things that, we know that there need to be significant technology improvements, and we're working on those. And we know that our governments are continuing to invest in our research, development, and deployment to do that. The regulatory path is still important. The US EPA, I know our first speaker spoke a little bit about the previous NOx story and the new emissions regulations in 2004, 7, and 10. But there is significant work to be done, and EPA is currently working on a regulation to continue to lower NOx. California just last year implemented their own new low NOx regulation. We think there's more to be done, and that has an impact. There are certain climate impacts that will come to it, but it also has a lot to do with air quality and the communities that are really bearing the brunt of that poor air quality, that are often least able to afford that brunt. I talked a little bit about the infrastructure readiness, and then of course we need to get the total cost of ownership of these new systems down, so that can happen with things like tax incentives or grants. But it also includes, when I talk about those regulations, certainly additional NOx control can increase the cost of an engine, and when you're seeing traditional technology costs increase and new technology costs decrease, that delta will be smaller, and so adoption rates will will change a little bit on the margin. So all of those pieces really have to come together in just the right way to accelerate the deployment of the latest and greatest technologies. And Cummins is committed to really working with our customers, working with our regulators and policymakers to do that in the way that makes sure that everybody wins. And I'll end with that. So thank you.
Thanks, Traci. Thanks to all the panelists today for your insights. That concludes the presentation section of our webinar. We had a lot of great information here today, and I know there's a lot of questions, but as you know, as these things go, we're running a little short of time. But I'm going to start us off with just one question, and maybe it's going to be the final one at this stage. But we've heard that there's a lot of technologies available. We know that there is a lot of policies in development in other regions. What would you say, and I direct this to all panelists, what do you say would be the first steps that BC should take to help this transition accelerate? And I guess part two, if you were giving insights to government or policymakers, what would you recommend to them? Dave, would you like to go first? I'm sorry, we're not hearing you.
Incenting adoption of technology, both ZEV technology, existing technology, but getting serious about it. You know, we talk about $1.9 million for the hydrogen co-burn. That's great. We have $1.5 million a year for a heavy-duty vehicle efficiency program. That's great. Let's get serious. If we want to do this, we need to turn the fleet over more aggressively. We need to get newer stuff on the road. We need to adopt alternative technologies. We need to incent and get serious about it and start spending the money required.
Thanks. Karen, can I ask you, with all of the experience that you've had and all the different regions that you've been working in, what would you say we need to do first in BC?
I think that one of the important things then, and we didn't get much of a chance to talk about it, was some strategic government procurement to act as those first markets for adoption, things that we, and you know, get the insight that we only get by doing and by deploying. But then I think there's a really important part around coordinating private procurement, incentivizing industrial adoption across sectors. And so Dave spoke about that, whatever those incentives look like. And so what CALSTART outlined then around the enabling market conditions and the enabling policies is really a playbook to start with, and then BC could tailor it as it best sees fits for its economy and its market conditions.
Great, thanks, Karen. Traci, any insights or advice you'd have for BC to start embarking on deploying some of these technologies?
I'll just say from industry's perspective, the more signaling we can get, the better. It's easier for us to invest when we know that the infrastructure is coming and where it will be, and that helps us work with our customers to help them plan their fleets. So just the more visibility we have to the plans and the more signals we get from government and that market's getting from government, the more it helps us all make smart decisions. So I agree with everything everyone else said, and those things all need to happen. But you know, just the longer lead times and the more visibility, the easier it is for all of us.
Great. Yeah, I agree. Nicolas, you're part of Ballard. Ballard has been a mainstay in the technology, clean tech sector in Vancouver and BC, leading the world in hydrogen technology. What insights would you have for policy and makers and government in BC to help advance deployment?
I think there's two things. I think we need to support and help fleet operators to do some demonstration fleets so they can see how you know, fuel cell trucks can operate in BC. So I think the support of demonstration fleets and in BC, and there are customers willing to do that. So I think, you know, helping that and really developing those hydrogen hubs. I think there's no point either to put a fuel cell truck on the road. There's no hydrogen and low carbon hydrogen, and we have a chance in BC to produce low carbon hydrogen from renewable energy we have. So support of the hubs, you know, in the Lower Mainland, in Prince George, in other area, in Kamloops and others, develop those hubs so we can have the production of affordable low carbon hydrogen in BC is very critical. If we don't do that, then there's no point with any vehicle on the road. So I think that would be, for me, the two key things: support demonstration fleet and the development of the hubs, hydrogen production hubs in BC.
Thank you. I wish we had more time to dig a bit deeper into this discussion. I know this is a starting point for some of the discussions that are going to happen following this webinar and in Pembina's future work. But just on behalf of everyone at Pembina Institute, I want to thank today's speakers, Dave Earle, Karen Hamberg, Nicolas Pocard, and Traci Kraus, for helping advance this important discussion with us. And I'm hoping it's not going to be, it's the first one that we're having, but not the last in BC. So, and thank you again to our Pembina team, Simon Dyer, Karen Tamwu, and Colton Castile for their assistance with today's event. And thank you to all of you for taking the time to join us today.